In AP Calculus, there are two classic problems. So these two questions led to calculus. All right, so the first question has to do with a tangent line. So it's finding the equation of a tangent line for a curve. Okay, so this example says find the equation of the tangent line to y equals x squared at the point 2, 4. So if I graph that out, and then I had the point 2, 4. Oops. Oh, I did that. And I wanted to find the equation of this tangent line. A tangent line to a curve never crosses. I mean, it just barely touches the curve and then goes along next to it. Now, you could have a curve where a tangent line, like let's say the tangent line here, it crosses in other places, but right there at that single point, it's just going to be right up against it, okay? Do you guys remember a tangent to a circle? Tangent touches, secant slices. You guys remember that? So tangent just barely touches your curve. All right, so if we're trying to figure out the slope of this tangent line, we use something called a derivative. So we have not learned how to take a derivative yet. We're going to do it right now. We did a little bit of this in pre-calc. We did not do it in summer pre-calc. Okay, so we're going to do it with a table first, and then I'm going to show you with the equation. So it says, in order to do this, you need to find the slope of the tangent line. So use the x values below to find corresponding y values. So if we're plugging into x squared and I have 2.5 squared, I get 6.25. All right, if I have 2.1 squared, do you guys know what that is? 4.41. 2.01 squared, you can put it in your table if you want to. Do you guys have that? 2.01. Like that, 4.0401. There's kind of a pattern. This next one is 4.004001, and this last one is 4.00040001. And you can do a table of values if you get confused. Okay, so in order to find a tangent line, we don't actually find the exact tangent line right now. We're just finding an approximation for it. So what we do is at the point 2, we have the point 2, 4, and then we pick points that are getting closer and closer to it. So if I was finding the slope between 2 points, I do my y2 minus y1 over x2 minus x1, right? So basically I connect those 2 points and I find the slope. And then I slide them closer. So I'm like, oh, well now I don't want 2.5, I want 2.1. And I'm going to connect those 2 points. So if I zoomed in on what's happening, I have this, and then I get closer, and then I get closer. It's really hard to draw. Until finally, you are almost exactly on top of that point, and you're getting an approximation for the tangent. Okay, so we're taking the points and we're scooching them in closer and closer and closer. All right, so let's find the slopes. So now you have another table. So when it talks about the slope of PQ, what I want you to do is we're going to do our slope. So we're between the point 4, 2 and the point, not 2, 4, 2, 2, 4, and 2.5, 6.25. We're going to find the slope between those 2 points. So your slope is going to be 6.25 minus 4 all over 2.5 minus 2. And when we do that, we get 4.5. All right, and then we're using this next one. Well, that was the point 2, 4, our original point, and now the point 2.1, 4.41 that we found in the last table. So we find the slope just like we do in Algebra 1, change in y over change in x. So 4.41 minus 4 all over 2.1 minus 2. Its slope ends up being 4.1. There's definitely a pattern. Do you guys see the pattern? This next one's 4.01, 4.001, and 4.0001. So all of these you're finding exactly the same way. So we're find using y2 minus y1 all over x2 minus x1. We're finding each of them exactly the same way. All right, so what do we predict that the slope at our point is? What's it getting closer and closer to? 4. So m equals 4. So if I was writing the equation of the tangent line with a slope of 4 going through the point 2, 4, we've done that a million times before in Algebra 2. We have our slope, we have the point, so it's going to be y minus y1 equals m times x minus x1. And remember, you can leave your answer like that. If you solved to get it in the form y equals mx plus b, it would be y equals 4x. We'd have minus 8, but then we'd add the 4 over, so we'd have minus 4. Okay, but remember, in AP Calc, you can always leave it in point-slope form, because if you go further and you make a mistake, you miss those points. All right, so do you guys understand what we did? We picked points, we made them closer, we found the slope between each of those points as we went closer. So let's try another one. So it says, consider the function f of x equals the square root of x, and now the point 4, 2. So right here we have 4, 2. So it says, graph the secant line passing through 4, 2, and also the points 3, something and 5, something. So if I'm at 3, that's 3 root 3, right? And if I'm at 5, that's 5, root 5. Do you guys see how I got the y value? Just plug it into the function. F of x equals the square root of x, right? It's on that curve, square root of x.
How do you know where to place it then? Like just ask.
There's a grid below. All right. So what we're going to do is we're going to connect the 2 points here, and then we're going to connect these 2 points here. So if I exaggerate this, here's what's happening. Here's my point. If I connect this one, and if I connect, let's say, these ones, and then I talk about the slope of the tangent line. Do you guys think that the first one between like 3 and 4, do you think that's steeper than my tangent line or less steep? Look at my picture. It's steeper, right? Can you see it? It's like more slanted up. Do you think the other one's less steep or more steep? Less steep, right? So we're probably going to find both of them and then find the average. Make sense? All right, so here we go. So let's find, so graph the secant line going through both of those. So we have those little secant lines, and then we're going to find the slope of each line. So the first one is going to be so if I'm finding the slope between my points at 3 and 4, the point at 3 was 3, root 3, and the point at 4 was 4, 2. So we're going to still do our y2 minus y1 thing. So I'm going to have 2 minus root 3 all over 4 minus 3. So I get 2 minus root 3. Oops. So if I was finding a decimal approximation for that, root 3 is like 1.73 something. So 2 minus that, I would have 0.2. So 0.268. That would be 3 decimals. All right, so what if I want to find the slope between the other ones? So let's find the slope between x equals 4 and x equals 5. Well, that again would be the point 4, 2, but now we'd have 5, root 5.
Is it not going to be the same?
It's not. Because we just said one is steeper than it and one is less steep. So root 5 minus 2 is going to be 0.236. So like I said, if you connect, so if you're on the square root function, we had 4 here and we had 3 here. This one is super steep. This one is less steep. The slope of the tangent line ends up being the, like, not the average perfectly, but it's going to be between those two. So let's go ahead and find the average. I think that's what I asked you to do in your homework. So we're going to add 0.268 to 0.236, and we're going to divide by 2. And you could have those stored answers as well if you want. But so we get 0.252. So that is a very, very good approximation. If I did the actual calculus behind this, there are shortcuts. Don't you guys hate this? I teach you all the long ways, and then I'll teach you the shortcut later. But if I do the shortcut, the slope ends up being 1/4. Pretty close, right? 0.252, really close. And that was not even using like anything that was super close to get together. I could have used like instead of 3 and 5, I could use like 4.1 and 3.9. Right? It's going to be even closer. Okay? All right, so I guess I did that here. So how could you improve your approximation of the slope? You could move the points even closer together. So use values that are even closer to x equals 4. So we estimated and got it was 0.252. All right, so the average rate of change of a function, this is a very important formula in AP Calc. So note card 1. So the average rate of change is just going to be your slope. It's f of b minus f of a all over b minus a. Okay, do you guys remember doing this in pre-calc?
Yeah.
All right, so we're just finding the slope between 2 points. All right, so if it says find the average rate of change of the function over the interval 1 to 2, we're going to find f of 2 minus f of 1 all over 2 minus 1. We're going to find that. So if you want to find f of 2 and f of 1 off to the side, you can, or you can plug it all in all at once. So f of 2 is going to be 2 cubed minus 2 squared. So 8 minus 4 is 4. And f of 1 is going to be 1 cubed minus 1 squared. 1 minus 1 is 0. So we have 4 minus 0 all over 2 minus 1. So we get 4 over 1, which is 4. So what we just approximated is this slope between those 2 points there, right? We had the point 2, 4, and we had the point 1, 0, and we found the slope between the two. Easy enough? Easy points in AP Calc. So every time you see average rate of change of a function, we just do f of b minus f of a all over b minus a. So we use the interval that we were given. All right, but if I ask for the instantaneous rate of change, it's a little bit different. So it says if we wanted to find the exact rate of change, so the rate of change at exactly 1.5, that means that on this graph, we would be finding the slope at exactly 1.5 right here. And it looks pretty similar, right? A lot of times they are very, very close to the average rate of change, but not necessarily. So in order to do this, we would use a different formula, okay? So for the example, it says compute the instantaneous rate of change of g of x equals x squared at x equals 3. So right here, we're going to find the slope of the tangent line. Okay, the first point is the obvious point. We're going to use 3, 9. The second point that we're going to use is going to be super close to x equals 3. So I'm just going to go over just a little smidge, and I'm going to put a point here, and that point is going to be 3 plus h, comma f of 3 plus h. I didn't write it very well. Can you guys read that? So 3 plus h, comma f of 3 plus h. Okay, so it's just a smidge. This is our super precise calc term, smidge. Just a smidge bigger. All right, and what we're going to do is in the end, we're going to slide them closer and closer together. Well, what do we do when we're sliding something together? We're using a limit. So we're going to take the limit at the end, okay? So what it looks like is f of 3 plus h minus f of 3 all over 3 plus h minus 3. It is the slope between those 2 points. Do you see it? y2 minus y1. Here's y2 minus y1 all over x2 minus x1. It's there. Do you guys understand that notation? So f of 3 plus h, or sorry, it's not f, it's g. I should have written it correctly. I said g of whatever. So g of 3 plus h means we're going to plug 3 plus h into here. Yeah? It's g of 3 is 9. 3 squared is 9, yeah. Yeah, so if I asked you like g of 5, we know how to find g of 5. We plug in 5 into the function, right? 5 squared is 25. So if I ask you g of 3 plus h, we plug in 3 plus h into the function, 3 plus h squared. Minus 3 squared. Well, 3 squared was 9, right? All over 3 plus h minus 3, it's just h. So we're going to FOIL. We're going to do 3 plus h times itself minus 9 all over h. So we get 9 plus 6h plus h squared, all minus 9, all over h. I just FOILed it out. And the 9 and the minus 9 cancel. So we get 6h plus h squared all over h, which we can reduce out by h. So you can do that little cheesy heart thing I showed you. You could do that first. Or you could factor the h to the front, and you have 6 plus h over h, and then the h's cancel. So either way you want to do that.
How did you get the 3 plus h squared minus 3 squared?
G of 3 plus h means your g of x function was x squared. So if I have g of 3 plus h, I'm replacing my x with 3 plus h. So I have 3 plus h quantity squared. Right, you're just plugging in this for your x value. All right, does this seem somewhat familiar? Do you guys remember doing this? All right, and then what we do at the very, very end is then we take the limit as h goes to 0. What would it be? 6. That's it. That's our slope. That's the slope of the tangent line at that x value. So it was at x equals 3.
Just plug 0 in for each, right?
Yeah, because see how we eliminated the 0 over 0 part? That's when we can take the limit. So you don't have to write limit each time. Just do it kind of at the very end if you want. All right, so the slope at 3 is slope equals 6. So write an equation for the tangent line at 3. Well, the point was 3, 9. So it's going to be y minus 9 equals m, which is 6, times x minus 3. Done. All right, so it would be nice if we had the instantaneous rate of change for any x value. So that was at an x value of 3, but it doesn't always have to be x equals 3. We want to find it for any x. All right, so this is the slope for any x value. And we end up doing this with the slope between these 2 points here. So x, comma, f of x, and x plus h, comma, f of x plus h. And we end up sliding them together. We take the limit as x goes to 0. We make them basically a single point. So we write this as the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, have you seen that before? I always love when I teach like consecutive classes because I'm always like, you did this in pre-calc, and everybody's like, I don't remember doing this in pre-calc. I totally did this in pre-calc. All right, so find the instantaneous rate of change for f of t equals 3t squared minus 2 at t equals 4. So you can plug in 4 right away if you want, or you can leave it as a general t value. It doesn't matter. We'll go ahead and use 4. So we're going to find slope between t equals 4 and a smidge bigger than it, 4 plus h. Okay. So if you want to find what f of 4 is and what f of 4 plus h is before you even begin, some people like to do that. That's fine. You can do that. So that's writing. F of 4 is going to be 3 times 4 squared minus 2. So I get 16 times 3 is 48 minus 2, so 46. And f of 4 plus h is going to be 3 times 4 plus h squared minus 2. And don't feel bad if you have to FOIL it out. When I was in calculus, I could not do 4 plus h times 4 plus h in my head. I was one of those students that had to write out every single step. If you have to do that, that's totally fine. So when we FOIL, we're going to have 3. And then when I FOIL 4 plus h times 4 plus h, I'm going to have 16 plus 8h plus h squared minus 2, because the outer and inner combined to be 8h. So we get 48 plus 24h plus 3h squared minus 2. So it simplifies down to 3h squared plus 24h plus 46. So let's write the formula. So we're going to do the limit as h goes to 0, and we're going to have f of 4 plus h minus f of 4 all over h. The h is really just 4 plus h minus 4, right? It's the slope formula still. So we have the limit as h goes to 0. The f of 4 plus h, we already did all that simplification before. So we had 3h squared plus 24h plus 46. And then minus f of 4, well, f of 4 was 46. If you do this correctly, you will have something that has h's on the top, no numbers by themselves. Do you see how the 46 and 46 cancel? That will happen every single time if you do it correctly. So we have the limit as h goes to 0. So what happens when I take the h into the numerator? What am I left with? 3h plus 24, right? So when I plug in h equals 0, I get 24. That's your slope. So this is the instantaneous rate of change. So in other words, it's the slope at that exact x value. So slope exactly at x equals 4. Or I guess t. It's always bad when I make it t's instead of x's. I always write x. All right, so t equals 4. So then last step, what's the equation of the tangent line? Well, we found our point. What's the point? 4 comma. It's in there somewhere. Right here. Yeah, that's the point, 4 comma 46. And we have our slope, which is 24, so it's going to be y minus 46 equals 24 times x minus 4. Done.
Do we always set h is approaching 0?
Yep, h always goes to 0 because what you're doing is you have some kind of curve. You have 2 points on the curve. So the first one is an x value of x. The next one is x value of x plus h. And you want to slide them so that they become 1 point. So you're sliding them together until they become a single point. That's what we do when we want to find the exact slope at an exact x value. So not between 2 x values. That would be the average rate of change, right? So if you want exactly 1, then you use this. All right, so let's do it again. So now I'm saying find the slope for the tangent line for any x value. So this means I'm going to have x's throughout my equation. All right, so we're going to use the formula. You do have to memorize this formula. It's not that hard to memorize if you just think about what it is. It's the slope. It's just like if I had x plus h minus x on the bottom. It goes to h. All right, so I'm going to say the limit as h goes to 0, and I'm going to have f of x plus h. So in my f of x formula, I'm going to replace every x with x plus h. So I'm going to have 2 parentheses x plus h squared minus 3 times x plus h, like that. If you want to put a big bracket around that so you know, okay, that's my entire f of x plus h, I'm good. That's fine. Then we have minus, and we're subtracting out the entire f of x. So I'm going to put a bracket around that as well. So that's my entire f of x formula. That one's the one where it is important to put the brackets or the parentheses or whatever. Okay, if you don't, then you'll forget to distribute that negative, and you'll still have like an x on the top. Your h's won't go away. So you'll know if you did that, because when you simplify down, you won't be able to divide out the h. Yeah, Katie?
So you just got the first formula by just plugging in
X plus h.
for every
That's it.
And that's what you do when it says any x value.
Yeah, if it says any x value, you have to leave x in there. But if it said add x equals 2 or whatever, plug in 2. So you'd have between 2 and 2 plus h. All right, so I'm going to do the limit as h goes to 0. And I'm going to have 2. When I FOIL x plus h squared, I'm going to get x squared plus 2xh plus h squared. You can do that off to the side if you get confused. Then I'm going to have minus 3x minus 3h. I distributed. And then I'm going to distribute the negative into the second part. So I'm going to have minus 2x squared plus 3x. And I get all over h. So I have the limit as h goes to 0. Continue simplifying. All of this is just basic algebra, just simplifying. So I'm going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h, I hate these, minus 2x squared plus 3x, all over h. See how I made my numerator into a double line numerator? Sometimes there's just not enough paper in calculus. Sad story. All right, then cancel things. So I have 2x squared minus 2x squared. I have minus 3x plus 3x. See how everything left on the top has an h in it? That's what we want. If you do not have that, you did it wrong. So we have the limit as h goes to 0. Can we bring the h into everything in the numerator? So divide the h into everything in the numerator. And we're left with 4x plus 2h minus 3. So as h goes to 0, don't say it's negative 3. Be careful. Only h is going to 0, not x as well. We have 2x minus 3. That is our slope for any x value.
How'd you get to 2x?
Oh, man. Yes, you're right. Darn, Katie got me. 4x minus 3. That is the slope for any x value. Does that make sense? So the h went to 0, the rest of it stays. You know I'm going to teach you all this, and I'm going to teach you a shortcut, right? You have to go through this pain for this homework. All right. So it says occasionally you're going to see a question that asks for a normal line. This ends up being just the line that's perpendicular. So we use the word normal because when we talk about 3 dimensions, how do you talk about perpendicular? Like perpendicular to what? So normal is going to be the word that we'll use. So normal means perpendicular. We're not talking about 3 dimensions, don't worry. All right, so write an equation for the normal line to the curve at x equals 4. So since we have the x equals 4, then we're going to do the limit as h goes to 0. We're going to do f of 4 plus h minus f of 4 all over h. So we can go ahead and plug in the x value since we set the specific x value. And this will be the slope of a tangent line. All right, so I get the limit as h goes to 0, and I'm going to have 2 minus 4 plus h quantity squared. That's the entire f of x plus h minus 2 minus 4 squared. That's the entire f of 4 all over h. So we get the limit as h goes to 0. We're going to have 2 minus, and I'm going to keep it in parentheses because I'm going to FOIL the 4 plus h, and I want to do 2 minus that entire FOILed part. So I'm going to have 16 plus 8h plus h squared. And then I'm going to have minus, what about the 2 minus 4 squared? Negative 14, so it's minus a negative 14 all over h. We continue simplifying. So I get 2 minus 16 minus 8h minus h squared plus 14 all over h. So I did minus a negative, made plus. So do you guys see how the 2 minus 16 is negative 14 and we have positive 14? Those are gone, just like we want. Anything that was just a number is gone. So we end up getting the limit as h goes to 0, negative 8 minus h. So our answer is negative 8. That's our slope. But this is the slope of the tangent. So basically, if you have a curve and you have the tangent line, the normal line is perpendicular to that tangent line. It's kind of what you need if you're like on a hill and you're trying to like walk up the hill. You need to be kind of like your force is perpendicular to the hill. It's kind of weird.
So it's equal to 1 over 8?
Yeah, so it's the perpendicular one. So we're going to use positive 1/8. So that's the slope of the tangent, or slope of the normal line. So what is the equation then? So we still have the point 4 comma negative 14. You guys see where I got that? Right here, negative 14. So it's going to be y plus 14 equals 1/8 times x minus 4. That's our slope of our normal line.
How'd you just like drop the negative 8?
How did I drop the negative 8?
And just find like negative 8.
Because I plugged in h goes to 0. Right?
Oh, right. Okay.
Yeah. All right, and then the last thing we have, I don't know, we don't have much time, is this is an area problem, so we'll do this next time, but this is going to involve some rectangles underneath this curve. So I'm going to give you your homework so you can at least start it. Do the limit ones.